Okay, this one's going to be similar to the one that we just finished working. A construction worker pulls a 5-meter plank up the side of a building by means of a rope tied to one end of the plank. Assume the opposite end of the plank follows a path perpendicular to the wall of the building, and the worker pulls the rope at a rate of 1,500 meters per second. How fast is the end of the plank sliding along the ground when it's 2.5 meters from the wall of the building? So, I mean, as you can tell, the picture you already have here. So he's standing on the top, got the rope, and he's pulling it up. Okay, so of course, as this end is being pulled up, this end's going to be sliding this direction. Okay, so given and find. So, of course, the 1,500 meters per second, of course, that's going to be one of your given rates. Now, you have a right triangle. Of course, that's going to be, I'll just outline it down here. This is the right triangle that you're going to be using, because like I said, this one's similar to the one that I just finished working. Now, just like it had the 6 labeled a while ago, this one already has the 5 labeled, because the length of that plank is not going to change. You know, regardless of how high up the wall it's been pulled, the 5 never changes. So this side, of course, is increasing as the plank goes up. This side's going to be decreasing as the plank is pulled up, because this end's going to be sliding in. Now, you don't have any variables here, so you can actually use whatever you want to. I'm going to work it by letting this side be X, and then I'll let this side be Y. You know, so you'll have on some of your problems choices that you can make with that. So I am given, let's see, assume the opposite end of the plank follows a path perpendicular to the wall of the building, and the worker pulls the rope at a rate of 15 meters per second. So it's being pulled here up this way, which means this side's increasing. So that's going to be dy dt, since that's what I chose to call that side. So dy dt is equal to 500 meters per second. Okay, so how fast is the end of the plank sliding along the ground? So that means we're going to try to find dx dt. Now, you're specifically wanting this rate of change when it finally reaches 2.5 meters from the wall. So if you're talking about the end of this plank reaching 2.5 meters from the wall, that's an X value that's given to you. So X is going to be equal to 2.5. All right, so again, we're still dealing with Pythagorean theorem. And I'll go ahead, x squared plus y squared equals 5 squared. And again, you're allowed to go ahead and put the 5 in before you do the differentiation, because it doesn't change. X and y are changing, so that's why you can't plug anything in for those just yet. Okay, so this would be 2x dx dt plus 2y dy dt. Of course, that would be equal to 0. Derivative of 25 would just give me 0. Okay, so I don't have y. Of course, I was given a value for x. I'm trying to find dx dt. I was given dy dt, so I've got to find y. And you'll do that again just like you did on the previous problem. So you would have, using the x squared plus y squared equals 5 squared. So x is 2.5. Okay, so y squared is going to give me 18.75. So y would be equal to plus or minus square root of 18.75. Okay, of course, you'll end up using the positive. Now, I'm going to go ahead and keep that right now, just because, you know, the more times you round, the less accurate of an answer that you're going to have. So I would have 2 times 2.5 dx dt plus 2 times, and we'll have the square root of 18.75. dy dt is the 0.15. And then that would be equal to, of course, 0. Okay, this is going to give us 5. And, of course, I'll end up multiplying the 2 times this, but once I multiply that, this is going to need to be subtracted, so you have it on the other side. So that's going to end up giving me negative 3/10 square root 18.75. So dx dt and all that divided by 5. Okay. Now just put this in your calculator and round it off now. So this would be approximately negative 0.26, and that would be meters per second. Okay. Now again, the fact that this one comes out to be negative, remember you're finding the rate of change of dx dt, and since this end is being pulled up, this distance here is getting less, so it makes sense that that comes out to be negative.